Hey, how's everyone doing today? So what we're going to look at in this video is multiplying binomials. And actually one of these examples, we're going to multiply a binomial times a trinomial. But we're going to look at two different techniques to do this. One is called the FOIL technique, which is really just the distributive property. And the other that we're going to look at is a more visual model. It's called the area model, which again is really just the distributive property, just done a little bit more visually. So what I'm gonna do is I'll use the left-hand column here, so numbers 1, 3, and 5, to use the distributive property, or the FOIL method, and then 2, 4, and 6 to demonstrate the area model. And I'll kind of alternate back and forth between those two methods. So let's go ahead and get to work. So problem number 1, we're asked to multiply the quantity x minus 5 times the quantity 2x plus 4. So what we need to do is make sure that each term in the first quantity gets multiplied times each term in the second quantity. So the pattern that some people like to follow is called the FOIL pattern, which is the multiply the first terms together. So x times 2x is 2x squared. Multiply the outer terms together. So x and 4, so we get plus 4x. Multiply the inner terms together. So negative 5 times 2x is negative 10x. And then multiply the last terms together. So negative 5 times 4, which would be negative 20. And then once you've done that, all you have to do to complete this is to combine your like terms. So 2x squared, there are no other terms that contain an x squared, so we're just going to leave that alone. We have 4x, and there is another term that contains an x, so 4x plus negative 10x, or 4x minus 10x is negative 6x. And then we'll look at the constant terms. Negative 20 is the only constant term. So your final answer in this case, when we multiply x minus 5 times the quantity 2x plus 4 using the FOIL technique, is 2x squared minus 6x minus 20. Now the other option that you have is called the area model, and really it's just based off of finding the areas of rectangles or rectangular region. So finding the area of a rectangle, we just multiply the length times the width. So again, this is a really nice, easy visual representation to help you out. So let's go ahead and try this out. So what we're going to do is we're going to think about these two expressions, so 4t minus 7 and 3t plus 1, as the dimensions of a rectangle. So we're going to think about this as the length of the rectangle and this is the width. So I'm going to draw a rectangle and I'm going to label it with its dimensions. So here 4t minus 7 would be the length, and then 3t plus 1 would be the width. And then what I'm going to do is I'm going to break that rectangle up into strips. So there's going to be a strip for 4t, a strip for negative 7, a strip for 3t, and a strip for 1. And now what you've seen that we've done is broken up the larger rectangle into smaller rectangles, and we're going to find the area of each of those rectangles by multiplying the length times the width. So let's go ahead and do that right now. So this first rectangle has dimensions 4t by 3t, so to find the area we multiply those dimensions together. 4 times 3 is 12, t times t is t squared. The second rectangle, so the one in the top right-hand corner, has dimensions 4t by 1, so 4t times 1 is just 4t. Bottom left-hand corner has dimensions 3t and negative 7, so negative 7 times 3t is negative 21t. And then finally, the last rectangle has dimensions negative 7 by 1, so that's negative 7 when we multiply those together. So now, same idea as in the previous example, we're going to combine like terms. So 12t squared is the only term that contains a t squared. Here we have a negative 21t and a 4t, so those ones can be combined to give us negative 17t. And then again, negative 7 is the only constant term. So this would be our final answer, 12t squared minus 17t minus 7. So So again, I'm going to continue in this pattern. I'm going to pick up the pace a little bit here, and we're going to multiply numbers 3 and 5. Okay, or complete these problems using distributive property or FOIL, and then we'll use the area model on 4 and 6. So let's go ahead and do that. So here we're going to multiply 3c minus 5 times 3c plus 5. The first term's 3c times 3c gives us 9c squared. The outer terms, 3c times 5 gives us positive 15c. The inner terms, negative 5 times 3c is negative 15c. And then finally, the last terms rather, negative 5 times 5 is negative 25. So again, we'll go ahead and combine like terms. Only one term that contains a square, so 9c squared. Positive 15c minus 15c is 0, and then we're left with negative 25. And I don't know if you remember this pattern from back in Algebra 1, but this is actually the difference of squares pattern. And that's something that we'll investigate a little bit further later on. All right, so again, let's try the area model on problem number 4. So again, I'm going to let this be the length and this be the width of the rectangles. So let's go ahead and label our rectangle. So 5k minus 2, that's the length. 2k plus 8 is the width. And now we're going to break that up into strips. So here's that strip right there to represent a width of 5k. Here's a width of negative 2. And then we'll break that up into 2 strips for 2k and for 8. So now we're going to multiply each of the areas, or we're going to find rather the areas of the smaller regions, and then we're going to add those up to get the area of the entire region. So 2 times 5 is 10. K times k is k squared. This region has dimensions 5k by 8, so that's going to give us 40k. This region, the bottom left-hand region, has dimensions negative 2 by 2k, so that's negative 4k when we multiply those together. This bottom right-hand region has dimensions 8 by negative 2. So when we multiply those together, we get negative 16. So now to find the area of the entire region, we're going to add up each of the pieces. 10k squared is the only term that contains square. Then we have 2 linear terms, negative 4k and 40k, so that's positive 36k when we add those together, and negative 16 is the only constant term. So the area of that region, the entire rectangle, represents the product of these 2 binomials being multiplied together. All right, 2 more examples left to go. Take a look at problem number 5. Now for problem number 5, what you're going to notice here is that's different is that you have a constant out in front of our first binomial. So here's my suggestion. If you're in a situation like this, I would multiply this constant through the parentheses first. So let's do that by using the distributive property. So 2 times 3x is 6x. 2 times negative 1 is negative 2. And then we're going to multiply that now using FOIL times the quantity x plus 5. So let's go ahead and do that. The first term, 6x times x, gives us 6x squared. The outer terms, 6x times 5, gives us 30x. The inner terms, negative 2 times x is negative 2x. And then negative 2 times 5, which are our last terms, give us negative 10 for a product. And again, we'll combine like terms. 6x squared plus 28x minus 10 is the product that we want. All right, now in the last one, again, as I mentioned at the beginning of the video, we're actually multiplying a binomial times a trinomial. But again, using the area diagram, really no big deal. It's just now, instead of having 2 strips vertically, we're gonna have 3 strips vertically. So let's go ahead and try that out. So again, we'll let this be the length and this be the width of our rectangle. So x plus 2 is our length, 3x squared minus x plus 5 is the width. So we'll divide the length up into 2 strips, one for the x and one for the 2, and then the width up into 3 strips, one for the 3x squared, one for the negative x, and one for the 5. So now we're going to find the area of each region. X times 3x squared, 3x cubed, x times negative x squared, x times 5 is 5x. Going to do the same thing for that bottom row. 2 times 3x squared is 6x squared. 2 times negative x is negative 2x. And then 2 times 5 is positive 10. So now again, we're going to find the area of the entire region by combining our like terms. 3x cubed is the only term that contains cube, so this is 3x cubed. We have 2 squared terms, so 6x squared and negative x squared. Add those together, we get 5x. We have 2 linear terms, negative 2x and 5x. When we add those together, we get 3x. And I apologize, this should be 5x squared. The next one should be 3x, next term, sorry about that. And then the constant term in this case is positive 10. So to be perfectly honest with you, this is really personal preference. Whichever method you prefer to use, it's up to you. I know that for some of the problems where we have a lot of terms, using the area model can really help you keep your work organized. But again, it's up to you, because essentially you're doing the exact same process, which is the distributive property, whether you FOIL or you use the area model. Hope this video was helpful, and we'll see you in the next one.